Well, cast your mind back to February last year and you may remember the excitement when NASA successfully landed its Perseverance rover on.
The vastness and infinity of space has long amazed and perplexed humankind. There's always been this nagging curiosity about whether or not we're alone in the universe and what mysteries might lie beyond Earth. Now, scientists from NASA have uncovered a surprising discovery. From a single, huge, deep space source, millions of radio messages are being delivered to Earth. What might they be, though? Do they have a natural explanation? Or is there another explanation? Due to the unparalleled scale and coherence of the signals, scientists have more questions than answers. Could this point to the existence of sentient beings in other parts of the galaxy? What are they attempting to tell us if that's the case? Let's find out. Fast radio bursts may seem like an uninteresting event to some, but it has fascinated astronomers, physicists, and space enthusiasts. Its cryptic character adds to its attractiveness because there is so much about it that is yet unknown. Imagine the excitement among scientists when they first noticed several fast radio burst signals in a short period of time and continued to do so. Who or what is trying to get our attention, and what might they be trying to get from us, is what we're left to wonder. Fast radio burst signals are radio emission bursts that last just a few milliseconds and are quick and intense. They possess the dispersion sweep possessed by radio pulsars. After examining archived data, researchers learned that a pulsar scan of the Magellanic Clouds took place about 6 years before Duncan Lorimer discovered fast radio bursts signals in 2007. The fact that the fast radio bursts are also referred to as the Lorimer burst should not come as a surprise. When telescopes record a fast radio burst, scientists pay special attention to a feature known as dispersion. Dispersion is a measure of how dispersed a fast radio burst is when it finally reaches Earth. Instead of being empty amid the expanse of space, the space between stars and galaxies is filled with plasma, a soup of charged particles. As light moves through space, it comes into contact with many different barriers which might alter its path. A part of these barriers is plasma. Radio waves and light can both be slowed down by this plasma. It's fascinating to observe that radio waves with lower frequencies are slowed down and influenced more than those with higher frequencies. A quick radio burst has several frequencies, and the dispersion effect happens when the higher frequencies reach Earth first. Scientists use this dispersion to determine how far away from Earth the fast radio burst's source is. The signal has traveled through more plasma with a higher dispersion, indicating a further separation from the source. The first time a fast radio burst was discovered, it was situated near the Little Magellanic Cloud and resembled massive radio pulsar pulses. The restricted apparatus prevented a precise measurement of the signal's flow, though. According to the researchers, there is a limited possibility of detecting the first fast radio bursts, which could happen in several hundred bursts per day. When the initial fast radio burst was found, scientists believed it to be a unique event because it only happened in 3 of the 13 beams of the park's multi-beam receiver. However, interest in the topic was renewed a few years later when a student by the name of Sarah Burke-Spallar found another burst with a dispersion that was almost equal to that of the Lorimer burst. Fast radio burst signals were given their official designation by Thornton and colleagues after they identified 4 additional Lorimer bursts in 2013. These bursts, which had substantially larger dispersion measures than the initial Lorimer burst, were discovered by high-time resolution universe surveys conducted with the park's 64-meter radio telescope. The brightest burst showed dispersion broadening with power law dependencies, as we would expect from alien radio emission sources. The first fast radio bursts found in a different observatory were announced in 2014, but it is still unclear where it came from, and scientists are still trying to identify it. Technology and study methodologies developments may help us comprehend these enigmatic bursts and their causes better. Researchers are keen to unravel this puzzling phenomenon. Hold on to your hats, people. The plot is about to get even more convoluted. After thoroughly analyzing their data, astronomers made a discovery in 2019 that would leave even the most experienced astronomer dumbfounded. The analysis showed that the fast radio bursts 121102 source broke the previous record for the most flares ever discovered from fast radio bursts, producing an astounding 1652 flares in just 47 days. As a result of this new information, a whole new range of research possibilities opened up, and scientists raced to identify any kind of regularity or periodicity in the bursts. Sadly, they were unable to find any patterns, therefore their efforts were ineffective. The experts really scratched their heads trying to figure out where the burst came from because there was no periodicity. They admitted that it might be some time before we fully understand the enigmas surrounding fast radio burst signals, and were left wondering whether these flares might be caused by a variety of mechanisms. The majority of fast radio burst sources only flare once before disappearing, which makes it considerably harder for scientists to forecast or find them. One of the few fast radio burst signals that have been observed to consistently generate signals is this fast radio bursts 121102, one of the most active fast radio burst signals. This strange object has been tracked by researchers all the way to a dwarf galaxy located 3 billion light-years distant. But it's not your ordinary fast radio bursts. It is quite congested and has only one pattern. After 90 days of activity, there are 67 days of silence. Due to the amount of activity it has seen, the 500-meter aperture spherical radio telescope, or FAST for short, has been one of the instruments that have assisted astronomers in observing the fast radio bursts when it is transmitting. Fast radio bursts signals were detected by the telescope even during its testing phase. In just 47 days, it gathered a staggering 59.5 hours of data in just 2 months. The highest level of activity ever observed in a fast radio burst source was the peak rate of 122 bursts in just 1 hour. The researchers were able to conduct a statistical analysis of the source's activity. As a result of this enormous collection of data, the bursts were categorized as those with a higher energy and those with a lower energy, whose properties were distinct from one another. It was demonstrated that the weaker bursts were more unpredictable. Despite their irregularity, scientists are persistent in their search for fast radio bursts. Through their investigation, they have discovered that although these bursts originate from galaxies that are millions or even billions of light-years away, they have the power to power hundreds of millions of suns in a matter of seconds. The FAST telescope just located fast radio bursts 190520, a fascinating new one that was unearthed in China by the researchers. This fast radio burst stands out because it repeats more frequently than others, releasing 75 bursts in just 6 months. In an effort to understand more, the team used the robust Very Large Array Radio Telescope in New Mexico to concentrate on the fast radio bursts. They eventually identified the mysterious signal's origin, which was a dwarf galaxy some 3 billion light-years away. They made an unexpected discovery when they found a weak radio signal coming from the same area as this radio signal. It is an unusual find because there is only one other fast radio burst signal source known to have this persistent signal. Using the position of the dwarf galaxy that fast radio bursts 190520 came from, the scientists were able to calculate its separation from Earth. However, an interesting disparity was found in their findings. The calculated distance, 30 billion light-years, was 10 times more than the real distance, 3 billion light-years, based on the fast radio burst's dispersion. Despite the fact that this is extraordinary and perplexing, it is crucial to keep in mind that just 19 of the more than 800 reported fast radio burst signals have been detected, enabling accurate distance calculations. For the remaining sources, astronomers must rely on dispersion to calculate their distance from Earth. The scientific community has been enthralled by this novel fast radio bursts, which poses more questions than it does answers. In contrast to the 19 other fast radio burst signals, on which the predicted distances matched the locations of the real fast radio bursts signal, the dispersion method utilized on this one was wildly inaccurate. Scientists are perplexed and forced to ask, Are persistent radio signals increasingly widespread, and what produces them? Is the same process that creates fast radio bursts also responsible for the persistent radio signal? The committee was also taken aback by the very high dispersion rate. Is it related to the fast radio bursts, or was it caused by anything close by? The crew is aiming to uncover additional information about this peculiar object by utilizing a number of telescopes spread throughout the globe. With further research, we might be able to unravel the mystery of fast radio bursts, leading to a better understanding of these strange objects in our galaxy. Despite considerable advancements in recent years, such as the discovery of more than 800 fast radio bursts and the tracing of some of them to their sources, there is still much we do not know about these bursts of radio energy. With regard to the unanticipated dispersion estimates and the discovery of persistent radio signals, the more we understand fast radio bursts, the more questions we have. However, by leveraging cutting-edge technology and cooperating with scientists from around the world, we can hope to learn more about these unusual things and get a greater understanding of our universe. A burst of radio waves, on the other hand, is coursing across space around 48 light-years away and is headed for a far-off globular star cluster. A message that was sent from a massive radio telescope that once stood in the jungles of a blue planet orbiting a dull yellow star is encoded in this radio transmission using binary ones and zeros. This is obviously referring to the Arecibo message, a pictogram of humanity that includes our composition, appearance, roughly a stick figure was used, location, population at the time the message was sent into space in 1974, method of transmission, and a blocky representation of our solar system that appears to have been taken from an early version of Minecraft. Messier 13, the intended recipient, is 22,000 light-years away. We're going to have to wait 44,000 years for a response, if anyone is even still there. Interstellar communication will never be as simple as making a fast phone call due to the size of space. We still try to contact whatever is out there despite the intimidating time frames. There have been a few attempts to communicate with the stars since the Arecibo message, and now a group of scientists from NASA's Jet Propulsion Laboratory, JPL, in California, have joined the fray by developing a new message that they call the beacon in the galaxy. The field of METI, messaging extraterrestrial intelligence, includes designing and sending communications into space. METI is the rambunctious brother, determined to kick over anthills and see if there are any little green men hiding behind, whereas SETI is about calmly and patiently watching for indications of life. It's a hot topic that divides the SETI community and is frequently contentious. What might happen if there is contact is the main topic of discussion. Those that favor METI think that contact would be very advantageous for humanity. We don't know anything about what aliens might be like or what unexpected implications our civilizations might face from engaging with them, say those who are wary of broadcasting our existence to the universe. Just to be clear, there are no immediate plans to transmit the beacon in the galaxy into space. For the time being, the goal is to generate conversation and improve our ability to create intergalactic messages. Although the goal is to convey a very straightforward message that is centered on scientific details, it seems that the real goal is to quietly influence an alien's perception of humans by only showing it in a positive light. The beacon in the galaxy is meant to portray us as explorers who are just interested in science and information, but if aliens were able to see our television broadcasts, they would see us in a different light. The Voyager Golden Record can be used as a point of comparison. Carl Sagan and his crew had to decide whether to accurately depict life on Earth, with all its horrors of war, poverty, discrimination, and so forth, or whether to modify the contents of the record to only portray our greatest features. They chose to go after the latter, in part because they didn't want to give the universe a message that could be construed as unfriendly. The beacon does not contain many messages or illustrations of love and peace, despite this intention to show humanity in a sanitized manner. It goes beyond that, since ET won't necessarily comprehend our civilizations, speak our languages, or even necessarily feel and perceive the universe in the same manner that we do. Therefore, the first step in any successful interstellar message must be finding common ground. METI often does this by using pure science. Cosmologically universal ideas like the quantum physical foundations of hydrogen atoms should be understood by technological aliens as well. The message then goes on to discuss ideas like the biology of life on Earth and human DNA, once that common ground has been established. A map is also included. To further emphasize the point, the beacon in the galaxy also features a modified version of Linda Salzman's illustration of a naked man and woman that was originally etched onto the plaques attached to the Pioneer 10 and 11 space probes, which are currently escaping the solar system after passing Jupiter and Saturn in the 1970s. Prudes attacked NASA at the time for launching images of nudists into space, but there were other more pressing issues. The two images ended up seeming Caucasian, which was not the intended result, and only the man had his hand outstretched in greeting, giving the woman standing by him the appearance of being in a subordinate position. A few years later, the images were altered to show the woman's hand raised in greeting and the man's hand down when they were published on the Voyager Golden Record. The man and woman's hands are now raised in the beacon to the galaxy's freshly modified edition. Of course, it's impossible to predict what aliens might think of them, since welcoming someone with a raised hand is a culturally specific human practice that they might not even be able to identify as such. The beacon in the galaxy, like the Arecibo message, is encoded in binary code, which researchers believe is the mathematical language that extraterrestrial life is most likely to comprehend. The binary is global, in our opinion. It's a language that any intelligent creature, as well as a computer, can understand, because it only uses the terms yes or no, true or false, and 0 or 1. Millions of years of yes and no merge to form decisions that make up our consciousness. Binary is therefore necessary for communicating with intelligent systems. The argument over whether humans should transmit into space has been revived by the beacon in the galaxy. However, some scientists do not view that as a negative. It might make us reevaluate our role in the universe, our chances of enduring into the far future, and what we can learn from any extraterrestrial civilizations we come into touch with. Because we're very young, and other species have had plenty of time to evolve throughout the universe, it is quite likely that extraterrestrials will be far older than we are, possibly by millions or even billions of years. As a result, SETI has frequently spoken in terms of connecting with higher powers, who are thousands of years older than us. When Carl Sagan argued that extraterrestrials could teach us how to prevent nuclear war, as they must undoubtedly have done to exist for so long, he was using this as evidence to convince Democratic Senator William Proxmire to endorse SETI. Some people question whether this is really depicting how Western civilization functions with respect to the rest of the world, or if it is more of a fairy tale. Without a doubt, there are many lovely, kind people who freely offer assistance and resources, but governments rarely do, at least not without conditions. Are we certain that we want humanity to owe money to an extraterrestrial race? Some individuals believe that sending interplanetary messages is a good idea, even though there is little possibility that aliens will notice them. However, by deciding what we want to say about ourselves, why we want to say it, and who gets to say it, we can learn a lot about ourselves and our society as a whole. We're still very early in the design process for interstellar messages, so mistakes are inevitable. Making progress will involve dialogue between people from all backgrounds worldwide, not only Western SETI specialists, in order to make our interplanetary communications more reflective of who we are all. We also have time. Distance safeguards us, assuming that aliens are not already present. We won't be exchanging texts with them, obviously. It would endure for thousands or maybe millions of years. This should allay concerns that we are harming the world by broadcasting too much or receiving communications from them. It will happen in the far future. The future generations of our children's children could be lucky. Let's hope they won't regret their luck when that day arrives. Thanks for watching another episode of Voyager. While you're still here, make sure to click the video on your screen for more mind-blowing videos about space.